Okay. So the third problem tells you to vote. If V equals 5 miles per hour. Should be an equal sign there would be, I got a minus sign in there, right in front of me. The vote if V equals 5 miles an hour. Requires 1,000 pounds of force. That takes 1,000 pounds of force to move through the water at 5 miles an hour. Fairly big boat. V equals 8 miles per hour. It requires 1,600 pounds. Our force is linearly related. We're going to assume the force is linearly related. To the velocity. Assume that the linear function of V. And we want to get that function. I think what I asked you to do, I didn't ask you to graph it. I didn't ask you to find the linear function. But since you were asked to find linear function in the homework, I would assume that you would then take this information and put it on a graph. I won't always take you by the hand and tell you, now graph this, now find the x-intercept, and so forth. Take your information and do the sensible thing with it to answer the question. We're trying to find the force. 20 miles an hour, right? Okay. Other ways of answering the question, and the way the comment stated, if you answered them that way, I would give you credit. If I ask you to graph by or solve this by finding the linear function, though, here's what you can do. Since the assignment was on linear functions, the reasonable expectation to do it this way. Another way to do it is using proportionality of sorts with slopes of fundamental triangles. Okay, and that would also be valid. If you want velocity to go up to 40 miles an hour, go up to 16 here. Do 8, 4, 12. And then 20 will be equal space for that. In my forces, 1,000, 1,600. Well, I'm going to want 1,600 pounds to go with B equals 8. So let's just do that. So I'm going to have a point like here. And 1,004 with the velocity is 5 miles an hour. So let's divide this out. So I see what 5 is. 1,000 is a little more than half of 1,600. So I'm going to put 1,000 here. There are other ways to scale the graph. So the linear function is going to look like this. Now, does that graph go through the origin? It looks like it might. And I'll give you a hint, if it goes through the origin, you have a proportionality, direct proportionality. And in this case, you actually do, but you don't always. So what are you gonna do? You're gonna come over here and you're gonna project up to 20. You're gonna project over here. So we have to take the x-axis, the y-axis, make it even higher. And you estimate what this point is, and then you work out the equation and get a good result. Looking like 1,600, 3,200, 600 or so more. I'm estimating 3,800. I'm not going to do it exactly. Okay, so the equation of F versus T, it's a straight line. So F equals MT plus V. I'll use that for this, V here instead of Y and X. Now, if you want to use Y and X and then say, okay, Y stands for the force and X stands for the speed, that's okay. But I'm going to do it this way, so I don't have to do that extra step. Well, I see the run is 3, the rise is 600. So the slope is 600 over 3 or 200. No, I'm not going to write out all the details of that for time because we just wrote out all the details. I would expect you to put in the details. One good reason for doing that is if you put in the details and screw up one little thing, but you have all the details, and your procedure's right, then you're going to get more partial credit on a test. Okay. So anyhow, now we know that M is 200. And you choose the first point or the second point. Both. You want the first point or the second point? Both for the first point. Okay, both for the second point. Okay, 2 to 1. The second point won this. Okay, second point, Y second is 1,600, or F is 1,600, and T is, it's not T, it's V. T rhymes with V, so I got confused. M, V. Okay. F equals 1,600. T, no, it's not T, V equals. So now 1,600 equals 200. V is 8. 200 times 8 plus V. And you get V equals 0. So this does go through the order. Look like it might. If I draw it on, it comes up a little higher. I have to draw a big order. Okay. That goes through the order. Now, F is a function of V, so I'm going to write F of V. Out. Emphasize that it's a function of V, and that's 200. Now, we want to know what F is if V equals 20 miles an hour. Yeah, that works. We just plug 20 into our equation, and we get 4,000. Well, my estimate here was 3,800. That wasn't too bad of an estimate. This is how we obtain a linear equation. And one example of an applied problem. take our information. You should get at least 2 points on the graph, or maybe a point and a slope. If we get a point and a slope, we can do this. We got a point, we know F and B. We got the slope, we know F, we find B, we get done a lot quicker. If we got 2 points, we got to calculate the slope and then do this. It's fairly simple if you practice.